Yes?
Methane.
Methane. So it is M-E-T-H. Instead of A, you make it E-N-E. Right? Do you agree with her? You don't. Why not? Good afternoon, class.
Good afternoon.
This afternoon we're going to talk about hydrocarbons. From previous classes, we already know that hydrocarbons are made of two elements, namely hydrogen and carbon. These are the two elements we find in hydrocarbons. Today, the emphasis would be on whether each atom of carbon has got the right number of hydrogen to be saturated or not. And then we'll carry out experiments to verify this. The IUPAC nomenclature, International Union of Pure and Applied Chemistry, the world organization that looks after chemical affairs, took nomenclature seriously because the ever-increasing number of hydrocarbons have required a systematic naming. So according to the IUPAC nomenclature, those saturated hydrocarbons end in A and E. And the number of carbon atoms will be represented by the prefix here. Like for one carbon would be METH, methane. With two it would be ethane. With three, propane, butane, pentane. Thereafter, we follow the Greek language. For 5 is pentane, for 6 is X, hence hexane. If it ends in A and E, it indicates it is a saturated hydrocarbon. And there is a general formula that governs this. For n number of carbon atoms, we will have twice as much plus 2 hydrogen atoms. For another class, these are the alkanes. We have unsaturated compounds that end in ENE, the alkanes. What is the corresponding alkene with one carbon? Yes?
Methane.
Methane. So it is METH. Instead of A, you make it ENE. Right? Do you agree with her? You don't. Why not?
I thought it was ethene.
Ethene. It should be ethene. Now, ethene has 2 carbons. My question was, what is if the alkane for one carbon compound is methane, the corresponding alkene for one carbon alkene would be, she said, methane. Do you agree with her now?
I don't think methane exists. Does it exist?
I'm not sure. Yeah, we can discuss that. You don't think it exists?
No, I don't think methane exists.
Why not?
Because Alkenes are unsaturated, and for unsaturated hydrocarbons, there must be at least 2 carbon atoms that are adjacent to form the double bond, so there's no methane.
Efrata, would you like to react?
I'll pass.
Do you agree with her? You still hold your belief that it is possible to have?
I think methane exists.
I think I will have to go with Liu. For a double bond to be present, at least we must have 2 carbons. A double bond can't be formed between carbon and hydrogen. Remember, hydrogen has only 1 valence electron, so its valence is 1. It can form only a single bond. So if we are going to see a double bond, it's going to be between 2 carbon atoms. And because we have only 1, it is not possible. So, Leo, you're right. Thank you. Okay. Now, we've seen this already in previous classes. But today, what I would like to emphasize on is how do we experimentally determine whether the compound, the hydrocarbon, the alkene, whether the hydrocarbon is an alkene or an alkane, whether we have a double bond or not. Over here I have bromine. If I dilute it, it becomes reddish, but concentrated, it looks darker. This is bromine, Br2. Is Br2 polar or non-polar? Lydia?
It's non-polar.
Non-polar. Are you sure? Bromine on the periodic table is found far to the right. They are elements of high electronegativity. Does that not make them polar? Yes, Fikr?
No, because they have the same electronegativity.
Okay, when we talk about a molecule, especially if it's diatomic, we're going to consider both. This molecule, Br2, is homonuclear diatomic molecule. The nuclei are identical. Whether they are very electronegative or less electronegative, it doesn't matter. Because when they share the electron pair between them, they're going to control it equally. So there will be fair or uniform sharing. You don't see one end becoming positive, the other end becoming negative. So it's not going to be polar. So therefore it is non-polar. So do you expect it to dissolve in water?
No.
Let's see. Okay, I'm going to take some water in this dropper and transfer it to a test tube. Okay. I don't want to contaminate my bromine, so what I'm going to do is use a different pipette. Okay, I'm going to transfer more so that we see exactly what's happening. It has to be stoppered. I'm not sure if you can see from a distance, but there is a liquid darker at the bottom. The bromine liquid is denser, heavier, and it has not dissolved. It is sparingly soluble. It has changed the color of the water slightly, but most of it is sitting at the bottom. So you can see that it is not soluble. Okay, now I'm going to see if it is soluble in carbon tetrachloride, I'm going to take another test tube. I better take clean but dry. Use another dropper to take carbon tetrachloride, suspected carcinogen. So I'm not going to drop it onto my It's always wise and judicious to take small amount. It's not always correct to think that if you take more, you get better results. It may not be so. Now I'll try to put about the same amount of bromine that I added to the water to Does it dissolve? Yes, it does. Okay. For the reaction that follows, I'm going to use this one, which is bromine dissolved in carbon tetrachloride to be added to this one, which is normal hexane, an alkane, a saturated compound. There are no sites where the Br2 can be added to, but I'm going to see. Okay. Pressure. Is it decolorizing it? You still have that beautiful red color. No discoloration. What does this tell you? This color persists. This is Br2. So this indicates we still have our Br2. It has not reacted with the normal hexane. Okay? I'm going to take an alkene, the simplest alkene. What is it? Radiate?
Ethene.
Ethene. Another name for ethene is ethylene. We call it ethylene as well. So I'm going to transfer some to this tube. Okay, over here I have ethene with a double bond in it. I'm going to add bromine to it and see now I'm going to shake. Maybe I've added a bit excess. Let's see what happens. It's not going away. Which one? Now we can have comparison. Which one is more decolorized? The one on the left, to me, with the alkene. So maybe I have added excess bromine, but whatever amount has been added to the alkene, in this case ethene, has been converted to dibromoethane. Because it is saturated, we call it ethane. Where is my chalk? So you have C2H4 plus Br. The pi electrons would attack this one, and this pair of electrons that used to be bonding now get possessed by this, and it becomes bromide. So you have carbon, 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 and a Br attached here. The Br minus, okay, for clarity, let me do it this way. Now this one, this has a positive charge because the electrons moved. This is the nucleophile, so you have carbon, carbon, Br, C, Br, C. No, H. How many carbons? 2. So it is an ethane because it is saturated. We don't see any double bond here now. But if you call this carbon 1 and this one carbon 2, it doesn't matter because we have only 2. This would be bromine at carbon 1 and bromine at carbon 2. So 1, 2, hyphen, dibromo, now no space, ethane. So this shows that the molecule bromine, Br2, has added along the double bond in ethene to convert it to an ethane type of molecule, which is an alkyl halide. Halogen is for group 7 elements, bromine is one of them, so it has been halogenated. We have dibromo ethane, but to be specific, the positions bromines are attached at carbon 1 and carbon 2. During addition on double bonds, you get across the double bond, so you'll have 1 and 2. But from other reactions, it's possible to have 2 bromines attached to 1 carbon. But that is not from saturating, unsaturated hydrocarbons. So this reaction has clearly shown that saturated hydrocarbons can add bromine. Why do we choose bromine? Couldn't we do it with fluorine? Kebron? Can't we use F2?
We couldn't.
Can't we use Cl2? They're all halogens. Why bromine? Radiate?
Perhaps we use bromine because it can clearly show us a color change in the test.
Very good. Cl2 is colorless. Fluorine is slightly yellowish, but it is not that visible. The bromine has a good red color which gets away when it's added across the double bond. So the bromine addition reaction is a test for presence of unsaturated sites. What other reactions do you know that could be used? Assume we didn't have bromine. What could we do? Yes?
Potassium permanganate.
Potassium permanganate would add hydroxyl groups in place of the BRs. So you would get 1, 2 dihydroxyethane if it was ethene. If it was propene, you would get, say, 1, 2 dihydroxypropane. If we use bromine, it would be 1,2-dibromopropane. Do you have questions? Okay, in that case, we're done for today. Thank you.